In this video, we're going to talk about solving inequalities, and this is sections 3.4 and 3.5 in your book. And our goals are going to be to solve inequality problems and then also to graph solutions on a number line. After you do this one, make sure you do homework number 4. So that's your assignment for tonight. Homework number 4 is due next class.
Let's talk about the inequality signs you know. You all have studied 4 inequality signs. They are greater than, less than, greater than or equal to, and less than or equal to. You need to make sure how to read each of one of these. So in your notes, make sure that you write next to each sign how you would say it out loud. So remember, the first one is greater than. The second one is less than. The third one is greater than or equal to, and the last one that we wrote down is less than or equal to. We're going to use these signs a lot in the lesson to come, and you need to be very familiar with them. Alright, what we're going to look at now is translating some sentences into inequalities. So if we have the sentence 5 is more than a number is going to be our variable, so we'll let that be x, and we know that 5 is the number 5, and is more than means greater than. So we have 5 is greater than x. That's our inequality. Let's look at the next one. This one says 2 times a number is less than or equal to 10. So if we have 2 times a number, this is 2 times some number that we don't know, that's x, is less than or equal to, so less than or equal to 10. So if I'm going to write that down, we've got 2x is less than or equal to 10. When you're doing these, make sure you underline important phrases or words to identify them. That's going to help you move a little bit more quickly through these problems. And then let's look at the last one. 9 is more than, so that's greater than, negative 3 times a number, negative 3 times x. So 9 is greater than negative 3x. So for each one of these, we've written a really nice inequality. Here's our inequality for the first one, here's our inequality for the second one, and here's our inequality for the third problem. Now, not only do you need to write inequalities, you need to be able to graph them. So if I'm going to graph these on a number line, what I'm going to do is make a number line, and when you're doing these, you don't have to put all of the integers on them like the number line I have up on the wall. You can just put this most important number on here. 5 is the most important number, so I'm going to put a 5 on there, and 5 is bigger than any x that you pick. Alright, now when we're looking at these inequality signs, we're always going to have open dots if we're dealing with a greater than or less than. So these guys get open dots. Okay, make sure you write that down. You need to know anytime that you're graphing something, you're going to have an open dot if you have a greater than or a less than. Now let's pick some numbers for x that would work. What numbers for x would 5 be greater than? So numbers for x that 5 would be greater than would be numbers like 4, x could be 4, x could be 3, x could be 3.5 or 4.5 or 4.99. X could be anything right up until 5. So x could be any of these values. A lot of times what you'll do is you'll draw an arrow that indicates x lives here. Or x can be anything right up until 5, but x cannot be 5, and x cannot be anything bigger than 5. So this is the graph of our inequality. So let's graph this one. Now to graph this one, we need to get the x all by itself, and you guys know how to do that. To do that, what you do is you treat this just like an equal sign, and you put a line through the inequality sign. You get the x by itself, you divide by 2, you divide by 2, and if we're going to rewrite that, what we have here is we've got x. The inequality sign stays the same, is less than or equal to, and 10 divided by 2 is 5. So again, on our number line here, 5 is the most important number. That's what we're comparing x to, so we're going to put a 5 on there. But now this isn't a less than or a greater than sign, it's a less than or equal to. So anytime we have a less than or equal to or a greater than or equal to, these get closed dots. Closed dots means we include the number that the dot is on. So closed dots go with the equals bar underneath the inequality sign. So I'm going to put a closed dot on 5, and x can exist anywhere less than 5. So what are numbers that are less than 5? Well, they're all over here to the left. So this is where x can be. Okay, so x can be there. Alright, so there's our number line graph. Alright, let's look at this last one. Now for this last one, this one's a little bit more tricky because we have a negative sign next to the x. So if we're drawing a line through the inequality sign and we're dividing each side by -3, we need to be very careful here. We need to flip the inequality sign anytime you multiply or divide by a negative. So put a big star. Remember, when multiplying or dividing by negatives, you must flip the sign. Alright, and I'll explain to you why this happens in just a minute. So, since we divided by a negative, we have to take our inequality sign here that was greater than, and we've got to turn it into a less than. So this is going to become -3 because 9 divided by -3 is -3, and this turns into 1, or just plain old x. Alright, so what we've got here is we've got a number line. We have a less than sign, so we're going to have an open dot at our important number, which is -3. And what this says is that -3 is smaller than any x values. That means x values have to be bigger. That means x has to live over here. You can also pick some values for x that work. X could be 10, 15, 35, 743. All of those numbers are to the right of your -3. Alright, so let's remember this important rule. Always flip the inequality sign whenever you multiply or divide by a negative number. So let me show you exactly why you need to do that. Let's say we're comparing -3 and 7. You know that 7 is greater than -3. Well, let's say I decide to multiply each side by a -2. Let's see what happens when we do this. -2 times -3 is a +6, and 7 times -2 is a -14. Alright, now let's compare the numbers. Now 6 is bigger than -14. What happened to the inequality sign? It flipped. So when we multiply by a negative, to keep the inequality true, you must flip the sign. The same thing happens with division. So let's look at a division problem. If I have 10 and 40, and I'm comparing them, 40 is bigger than 10. Now if I divide each by -2, what do I get here? I get -5 and I get -20. -20 is much smaller than -5. -5 is bigger. It's to the right of -20. So I have to say that -5 is greater than -20. Look what happened to my inequality sign. I divided both sides by a negative, and to keep my inequality true, I have to flip the sign. You just finished watching part 1, which was examples and explanations. Now you need to watch part 2 for practice examples with solutions.